Hello, ladies and gentlemen. I welcome you again to our last segment in the series of our marginal absorption, job, batch, service, and process costing lecture. Okay, so this is according to our Transcal Consulting Services schedule. This is week number 4. All right, so we are going to finalize our case with this video. All right, once again, I'm Mr. Jerem Timkulu, the lead ACCA tutor at Transcal Consulting Services. If you need more coaching, please feel free to contact me on the available numbers as shown on the screen, as well as you can email us at Transcal Consulting Services, and we are going to help you. All right, this is actually the best online business school for ACCA students. Right, so as I have already indicated, we have already covered absorption costing, marginal, job, batch, and service costing. All these have been covered in the previous 2 videos. Now in this final video, we'll be targeting process costing. All right, and what is process costing? It is a costing technique used in manufacturing environments which indulge in continuous production systems. Okay, so we are saying the production process does not stop. Okay, there are no batches. All right, the process is just non-stop. Okay, so how do we measure that? That's the issue. All right, but before we go to that, we need to understand which particular industry do this manufacturing system occur or is applied. I mean, where is it applied? All right, typically this is common in industries like the oil refining industry. Okay, oil refining industry for edible oils, as well as the crude oils in the to be used as part of energy oils. Okay, for motor vehicles, etc. They usually use these manufacturing processes. I mean, they use process costing. All right, even in the chemical works. Okay, in chemical works, they also apply process costing. But do not be shocked to see that even job costing is also conducted there, because it only depends on the particular job that is going to be done. But when we are talking of process costing, we are simply saying that the manufacturing process of this particular product takes place on a continuous basis. All right, so it might be in timber processing, right, where the production of timbers is actually on a continuous process. All right, they do not stop. All right, so that's how it works. All right, so in process costing, we have to work out the cost for the period. Okay, we work out costs for the period. All right, and we measure the costs that are used in that particular period and the output that has been produced. All right, and output that has been produced. We need to know all these. All right, I hope you guys, all right, if you're not seeing, let me just try to write this information on a more clear sheet. All right, like I've indicated, process costing is common in industries like the oil refining industry, okay, where we end up having products like petrol or diesel. Okay, these are produced on a continuous basis. All right, so the main point here is production is continuous, non-stop. Okay, so by the end of the day, we have to measure uh, or work out costs for the period. Okay, and then and also output for that period. Okay, so we may be like if we start a period with certain materials, and then at the end of the period all the materials and the finished goods would have been done in that particular period, then that would be actually a very easy way of doing things. All right, so we are going to start with an example that typically, gives us that impression that when we start with our raw materials, we are going to finish those, working out on those raw materials into finished goods within a particular period. Okay, but you discover that that is not really the case. All right, that is not really what is obtaining on the ground. But let us go step by step. So we are going to start with a certain example, and from this example we will then have to work out our case. All right, suppose we are given the cost for February. Okay, cost for the month of February. All right, we are told that in this month we had material costs, which were 100,000 units. All right, 100,000 units costing. They were costing $20,000. All right, and then we had labor costs, which were costing about $10,000, and then overheads were costing $5,000. Our output was 100,000 units. Now, what is the cost per unit? Okay, what is the cost per unit in this case? All right, the cost per unit should be given as follows. Cost per unit must be the total cost which we have incurred so far. So we are saying we incurred this much for materials, that much for labor, and that much for overheads. So that's 20,000 plus 10,000 plus 5,000. Okay, and then we have to divide all this by the number of units produced. All right, so we produced 100 20,000 units. So we are going to say 20 plus 10, 30 plus 5, 35. So the total cost was 35,000, all divided by 100,000 units. So the cost per unit would be 0.35. That's our cost per unit. All right. And the examiners would want us to do a process costing account. Okay, a process account for this. So we would say process account. Okay, and remember, an account is usually presented in the form of a T. All right, so that's a T account for the process. So we'll be having two columns on the debit and two columns on the credit side. All right, one of the column will be for the quantity and the dollar. All right, or the units and dollar. All right, so this is our debit, this is our credit. Okay, so we debit with every cost that has been incurred in the process. So we start with the materials. The input was 100,000. Okay, so in this case, in this particular example, the inputs were 100,000 units, and the output were 100,000 units, which means the assumption is that there were no losses, there were no wastages throughout the process. All right, but you discover that there would be some leakages, some filtration, some evaporation, some wastage that might happen along the way. Okay, but in this particular example, such wastages are not there. So the units were 100,000, okay, which were costing 20,000. And then labor, we do not have to worry about the labor hours at this moment. All right, so we are told that the cost was 10,000, all right, for the labor, and then the overheads was 5,000. Overheads 5,000. All right, so that is that. We are also told that the finished goods, all right, to finished goods transfer. Remember, you can put a double line on this sender line so that you know this is the sender. All right, so transfer to finished goods, we are told that there were 100,000 units which were transferred. All right, there were 100,000 units which were transferred. At what cost? They were transferred at 35 cents, because we have already determined that this was 35 cents, $0.35. So at 35 cents. Okay, that was the transfer. Okay, so with this information, we can actually complete our table to see that if they were transferred at 35 cents, therefore the total output, the cost of output, should be 35,000, because 100,000 multiplied by 35 cents, that's 35,000. All right, then we have to total up our columns. They should balance. These columns should balance. Okay, the debit quantities should equal the credit quantities, 100,000 units, and then that should all add up to 35,000. Sure, that has been done properly. Okay, that's our process account, ladies and gentlemen. Let's move forward. Now, in this case, we now have got losses involved. Okay, our process has not been 100% up to scratch. In terms of wastages, there have been some wastages. All right, so like I have indicated, when you do processes involving some liquids, sometimes those liquids end up evaporating or they could be lost due to some filtration processes involved. All right, so if you can't make units without some losses, then the cost of that loss is spread over the or to be absorbed into the good units produced. So whatever loss we incurred, we should account for it in the cost of the product. All right, so the loss is just another cost on the way to good production. All right, so it is actually normal to have such a loss. So when it is normal, then we have to actually consider the following formula, where we are saying the cost per unit. The cost per unit should equal to the total cost for the period, cost for the period, all divided by the expected good units. The expected good units, spelling for units, I don't like it. Expected good units for that period. Okay, let's suppose we had 100, I mean, 1000 kgs. Okay, 1000 kgs as our inputs. Okay, 1000 kgs at how much? Let's say at $3.60. All right, 1000 kg at $3.60 per kg. All right, which have been input into our process. Okay, and we suffered a 10%, okay, loss suffered, okay, due to some filtration process. All right, so we end up having, what would be the output if we lose 10%? Output would be equal to 1000 multiplied by 100% minus 10%, so multiplied by 90%, and we are going to get 900 units as output. Okay, so in this case, the cost per unit, according to our formula, cost per unit should be 900,000 good units. Okay, should be 900,000. I mean, should be based on our good unit of 900. Where is my pen? I'm not seeing my pen now. Okay, I found it. All right, it should be based on the 900 units which have been produced. All right, and we then have to say the cost for the period. Now we have to determine the cost for the period. We are told that the cost for the period was 1000 kgs multiplied by $3.60 per kg as given. Okay, because we are told here that the inputs were 1000 kgs at $3.60 per kg. All right, so we then have to say divided by the expected good units. All right, which are 900. Okay, so this is how we have to deal with this. So this means that 3600 divided by 900, we are going to have $4 per unit. That's $4 per unit. Okay, now you could see that our units are now more expensive because of the loss which we suffered. Initially, they were costing, as we can see, they were costing $3.60 per unit, but now they are now $4 per unit because of the loss which had to be incorporated into the cost of producing the product. Okay, but sometimes, let's say we were producing timber, all right, we were producing timber. Okay, sometimes we might recover something from the losses which we expect, or which would suffer along the way. All right, let's say we have already expected that we'll suffer about a 10% loss. However, that loss, from that loss, we could recover something to ensure that our production costs are not going to be higher. We will recover something from. In this case, we had not recovered anything on the 10% loss. We assume that the loss was just disposed of at zero value. Okay, an example of a loss that could be recoverable is a situation where, for example, we are in oil refinery. Okay, let's consider the oil refinery case. When they process crude oil, they normally they would normally be aiming to produce petrol and diesel or some other special liquid, which they might call jet A1 or jet A whatever. Okay, for those other form of for those aircrafts. All right, then this would be their main agenda. Okay, but along the way they might suffer, ending up producing some poor quality liquids which they call paraffin. So this is actually a normal loss, but they do not dispose of paraffin for free. Normally they charge some value. So in that case, the normal loss has got some scrap value, would be having some scrap value, and that value is actually part of the recoveries. All right, so let us consider a situation where we've got a normal loss with some scrap value. All right, so consider, for example, okay, a situation where we have got 1000 kgs. All right, and as our input at $4 per kg, $4 per kg. All right, and the loss has been 20%, normal loss. Okay, and this is due to some evaporation that has taken place. All right, and this loss could be sold at let's say scrap at let's say $0.50. Okay, that's our scrap value per kg. Okay, per kg or per kilo. All right, so in this case, what would be our good output? Obviously, good output would be 1000 kgs multiplied by 80%, because we have suffered the 20%, so we are going to have 800 kgs, 800 units as our output. All right, so in terms of the monetary value of the output, this would mean the cost per unit of output using our original formula now, because our formula here is this one that is going to guide us. All right, so the cost for the period have been 1000 kgs at $4 per kg. All right, according to this statement there, that has been the cost, but we are recovering something to reduce that particular cost. We are recovering, remember, the inputs were 1000 kgs, but the output are now 800, so the loss has been 1000 minus 800, which means 200 kgs have been lost along the way. So the 200 kgs are going to be input here, and we are saying we are disposing of these 200 kgs at 50 cents. Okay, at 50 cents. So we are saying multiply by 0.50 or over the good output from the formula, expected good units of 800 units. 800 units. So that's 4000 minus 200 by 50 cents, that's 100. So that's 4000 minus 100 minus 100, all divided by 800. So this means 3900 divided by 800, which gives us about how much? Let me use this calculator. 3.9 divided by 800. So we have 4875, $4.875 per unit. Okay, this is per unit, $4.875 per unit. You can call it, or you can just approximate it to $4.88. All right, that will be our cost per unit, and then you can come up with the process account for that information. The process account should look like this. As usual, we have got our materials. In terms of the units, said units or quantity, dollars, units, dollars. The units were input as 1000 kgs. These were the unit inputs, and they were costing at $4 per kg, so that's $4000. Okay, so you can just say this side we have got 1000 units at $4000. Okay, then we go to the transfers. All right, we have to first consider the normal loss. The normal loss was 200 units. Okay, because we suffered 20% loss, so 200 units, and these units are also at the cost per unit which we were given. The cost per unit was, the recoverable recoverable value of the normal loss was 50 cents, as you can see there. So that's their value at 50 cents. That's a dollar sign. Okay, so it means in total they cost $100. We then have to work out the transfer to finished goods. this could be transferred to another department for further processing, but let us assume they were now fine as fine output. So we are having a situation, because remember, the debits and the credits should balance. Here we should get a total of 1,000 and here a total of $4,000. So the balancing figures, so transfers now are now balancing figures, the balance. So here obviously we should have 800 units being transferred out, and then here the balance should actually be 4,000 minus 100, that's 3,900, as we have already computed. So from this again, you can also determine that the cost per unit, obviously the cost per unit of finished goods is actually equal to 3,900 divided by 800, which is also going to lead us to 4.875 per unit. Okay, but while this will be expecting normal loss, it might also happen that further losses might be incurred. All right, and those further losses which we were not expecting, we call them abnormal losses. Okay, okay, so our case becomes interesting, where we on top of expecting some normal loss, we end up having extra loss. Okay, we end up having some extra loss, which we call an abnormal loss, or we end up having producing more quantities. Although we were expecting some loss, we end up producing more quantities. Then in that case, we'll be having an abnormal gain. Let us go back to this particular example again, where we say that according to our computations, we determined that the good units were supposed to be 800 units, as you can see here. All right, the good units, after factoring in the normal loss, became 800 units. All right, now the issue is, what if we had produced 750 units instead of 800? Then the 50 difference would be abnormal loss, abnormal loss. Okay, or what if we had produced 850 units instead of 800 after factoring in the normal loss? It means the 50 units, the 850 minus 800, 50 units would be abnormal gain. Okay, that's the idea. But the issue now is, at what value are we going to value these goods? Are we going to value them at the normal loss value, or are we going to value them at what value? Okay, one thing we have to understand is that each unit of abnormal abnormal cost or costs would actually be costing the same way as the cost of the finished goods. Okay, in other words, you would you could simulate the abnormal loss by removing the fifth, the fifth goods which have been produced. The fifth goods from the finished goods output. Okay, those goods which have been produced right or in the good state, you could just, let's say, deduct the 50 units from those goods, and you would discover that the loss you suffer is actually the loss. Let's say if it is maybe by theft, you would actually suffer the same loss you would have suffered in producing the good quantities. So it is different. It is treated in the different way as a normal loss. In this case, we have lost the actual goods. The actual good quantity would have been reduced from your package or from your output. All right. Similarly, the value of the good units which were produced extra, okay, when let's say we produced 850 when we were expecting to produce 800, those extra 50 are just valued the same way as the good quantities. All right, so the values of these abnormal losses or abnormal gains is actually in terms of the good quantities. I'm sure we are together, because although they are abnormal gains, they are just the good output as the normal gains, which as the normal goods which have been produced within our budgeted expectations. All right, so we can just get through this example and illustrate this point. All right, uh, suppose suppose we just use another pen. All right, suppose 2000 units 2000 units are input to your process, okay, and then a normal loss of 5% of input, normal loss of 5% is of input is experienced, and there are no opening and closing inventories. Normal loss of 5% of input is experienced, and there are no opening and closing inventories. The actual output is 1,800 units. Okay, calculate the abnormal loss. All right, so what we first have to do given this situation is to determine the normal loss first. Okay, so what is our normal loss? Normal loss is equal the percentage expected loss, that's the normal loss percentage of 5%, multiplied by the quantities of inputs, 2000 units. All right, and this should mean that we have got a normal loss of 100 units. All right, so what about the actual loss? Actual loss suffered. All right, the actual loss suffered from the information, we had 2000 units, okay, but we produced how much? 1,800 units. So we have got 200 units of actual loss. So obviously, therefore, abnormal loss is equal to actual loss minus normal loss. All right, and this should take you to the actual loss were 200 units according to our computation here. All right, minus the normal loss 100 units, and we get 100 units as our abnormal loss. We had expected to incur a loss of only 100 units. However, we suffered 200 units. So obviously the extra loss was the abnormal loss of 100 units. Let's now consider an example where we'll be dealing with abnormal gains. All right. Suppose 2000 units are input in a process or to a process. All right. Normal loss is also at 5%, okay, of input, and there are no opening or closing inventories. You will discover as we proceed because of our time, the time has already gone, so we are going to have another video that is going to actually append everything, conclude everything with regards to process costing, because we have to consider where a situation where we'll be having the opening and closing inventories, and also the issue to do with joint product and so forth. Then we conclude our case. So this might also need about a 30 minutes to 1 hour explanation. So we can't continue having such a long video, because that might distract your comprehension and also your attention. Okay, just bear with me, bear with us, because we should base our videos in terms of international practice. All right, the more you lengthen your video, the more you are going to distract the students' their attention or interest in actually learning from the video. Okay, so an hour length video is actually the normal practice, especially at foundational studies. All right, so suppose 2000 units are input in a process. Normal loss is at 5% of input, and there are no opening or closing inventories. All right, the actual output is 1950 units. Determine the abnormal gain. You just have to base your answer on principle, on sound principle. All right, you know that we first have to consider the normal loss. Okay, normal loss, and we are told this is 5% of input of 2000 units. So obviously that's 100 units. And then the actual loss suffered was 2000 units of input minus the actual output 1950 units, and we are talking of 50 units. Okay, so obviously there's been some abnormal gain. The abnormal gain is now 100 units minus 50 units, which means there is 50 units more. Okay, that is it, and we can now have to take another example which might assist us in understanding the process accounts which should be incorporated in such a situation. All right, let's take down this example. All right, sorry, let's just take down this example so that's okay. Before we do end summaries here, think there is need for us to take down this example so that, all right, suppose 1000 units 1000 units at $4,500 are input to a process. Okay, and normal loss as usual is 10%, and there is no opening and closing inventories. The scrap has a value of 0.9 per unit. Number completes the process account and the abnormal loss or gain account if actual output is 860 units. All right, if the output is 860 units, okay, all right, so that the actual loss is obviously the input were 1000 and we obtained actual output of 860. So actual loss is actually the difference, which is 1000 minus 860, which is 140 units. The 140 units. All right, and then we talk of part B. All facts are the same except that the actual output, okay, actual output is 920 units. All right, so that actual loss is 8 units. So let us have a go to this example, all right, so that we know what to do. All right, so in the exam, I mean, these are actually typical exam questions. All right, no one is going to tell you calculate an abnormal loss, calculate an abnormal gain, this and that. All right, you just have to lead yourself. All right, just have to lead yourself if an abnormal gain has resulted or an abnormal loss has resulted. All right, so this, for the purpose of learning, teaching, we would be hinting you what to do. All right, so in the first part A, we have been told there that for part A, the output is 860 units and normal loss is 100 units. All right, output is 860, because this was actually the 860 units. This was the actual output. All right, but the normal loss is based on the percentage of 10%. All right, so 10% of 1000 units, that's 100. So that's 100 units is the normal loss. Which means the extra 40 units loss is the abnormal loss, because the input was 1000 units, but we actually produced 860. All right, but we know that there was a 10% normal loss, which means we're expecting to produce 900 units. All right, but unfortunately we produced 860 units. So the normal loss was 100 units, and then the abnormal loss was 40 units. So the cost per unit should actually be determined by the cost for the period, okay, minus scrap value of normal loss divided by the expected good units, good output. And the cost for the period, we are told from the question that they were 4,500. Okay, 4,500. So that's 4,500 minus the recovery value. The recovery value of the normal loss. Normal loss was 100 units. 100 units. Okay, at what value? According to the question, this was at 90 cents. Okay, it's 0.90, all divided by the expected good units. Expected good units, ladies and gentlemen, is just the input less normal loss. The normal loss is 100 units. The input were 1000. So 1000 minus 100 units, we get 900. That's the expected production, expected output. So in this case, we are going to have, this will lead us to a situation where we have got a cost per unit of $4.90. That's the cost per unit. Just have to use your calculators. Ladies and gentlemen, you must have calculators around you. All right, now let's do the process account for this information for part A. Okay, process account. The process account, you now know at this level that there is some quantities, some dollars, quantity, dollars. Okay, the costs incurred costs incurred, or the materials actually. All right, cost incurred, the quantities were 1000, okay, and they were costing 4500. All right, then you can just total up, just leave a space because other items might get in, okay, and you know at this level that the debit and the credit should balance. Obviously, for this part we are just going to say now the transfer part is actually the problematic one. So we start with the normal loss as usual. Normal loss, we know that the normal loss was 100 units, right? And these are valued at the recovery value of 90 cents. All right, the recovery value of 90 cents, because the question is saying that the scrap value was 90 cents as we have seen already. So we just have to put normal loss at 90 cents so that we are not going to be confused. So we are getting our $90 there. All right, and then output now, transfer to finished goods. Output, the output now is based on the cost per unit, which we have just calculated here. Okay, so the good output to start with, let's talk of the good output. The good output was 860, the actual good output 860 at the cost we have just calculated as $4.90. So at $4.90, that's $4.90 multiplied by 860, we have got 4,214. All right, but we know that these, if we add them up, they should come to 1,000. If we add them up, they should come to $4,500. So the difference should be the abnormal loss. Okay, and this abnormal loss is also valued at the cost of good output, because we explained that this will be valued at the cost of good output. Please replay that part of the video so that you are not going to be lost in the jungle. All right, so using the balancing figure approach, you will discover that if you say 100 plus 860, you are going to get 960, and 960 minus 1000, there's a difference of 40. Okay, so the abnormal loss is 40 units, and these are valued at $4.90, the cost of the good output. So which means the difference would be $196. So if you add up, it should come to 4,500 there. So that's the first part. Do I still have space? Yes. So let us consider the part B of the question. In this case, the actual output is 920. All right, so you just write the few notes as we did before. All right, so the actual part B, the actual output is 920 units, and normal loss was 10% of 1000, which is 100 units. Okay, so what about expected output? Expected output, if normal loss was 100 units and the input was 1000, so expected output was actually 900 units. Okay, so expected output was 900 units, but we produced 920 units. So was there a normal loss or a normal gain? Was there an abnormal loss or an abnormal gain? Obviously there was a gain because we produced more, so 20 units. Abnormal gain. There was abnormal gain of 20 units. So in that case, what we do is we then say we come up with the process account. And remember, the abnormal loss or abnormal gain are valued at the cost of a good unit. Always remember that. Otherwise, you'll be in trouble. The normal loss or normal gain, abnormal loss or abnormal gain, they are valued at the cost of good units. All right. So we are having the quantity or units produced, and then the dollar, quantity, dollar. This is the debit, this is the credit. All right, so we have the cost incurred so far. All right, the cost incurred, we are told by the examiner that 1000 units were input at 4,500. All right, and then we are also told that there was normal loss. Okay, there was normal loss. All right, the normal loss was scrapped at 90 cents per unit. All right, so we just have to say 100 units multiplied by 90 cents, they give us $90. All right, and then we are also told that the actual units transferred, output, which was transferred to finished goods, the finished goods account was transferred at the cost. We have already computed it as above. All right, this is the computation. Remember, in the computation of the output cost, the cost per unit, we do not involve the values of the abnormal gains or abnormal losses. Okay, they do not affect the computation of the cost per unit. Do not be confused in the exam. All right, because sometimes the examiner might ask you the abnormal losses or abnormal gains affect the cost per unit. They do not affect. Please watch out. They do not affect. So once you calculate the cost per unit, you are done. You just use the same figure. All right, so at $4.90 as usual. So the actual output we are talking about, according to the question, was 920. That was the actual output. All right, so multiply by $4.90 and we are going to get our 4,508. All right, you just have to close your brackets. Okay, now we then have to proceed with our computation. All right, we have to proceed with our computation. Now, as you can see, we had a quantity of 1000, okay, of inputs. But the process now, when we input the materials in the process, instead of suffering a 10% loss, we actually ended up producing more. Okay, so this means we had an abnormal gain. All right, so if we add these quantities, you can see that they've already exceeded 1,000. Okay, so we are having here a 1,020 and a total value of, if you add up, that's a 4,598. So we just have to take these figures as they are, 4,598. So obviously the abnormal loss, the abnormal gain is actually going to be this part. Okay, abnormal gain. abnormal gain account, right? And the abnormal gain is also valued at the cost per unit as we have computed. All right, so the abnormal gain, there were 20 units at $4.90, and we get $98, and they should actually then balance. So we can then come up with the abnormal loss or gain account. Abnormal loss or gain account, because we are dealing with the abnormal gain situation now. We are going to say that we have got units, we've got dollars, units, dollars. All right, so we know that we have a scrape. Okay, we had a scrape account which is in subsistence. All right, okay, we have got a scrape allowance, a scrape account that is in existence so far. But this reminds me of an omission which we made. All right, let us try to just navigate our path back a bit. All right, when we did this process account for the abnormal loss, we forgot to draw we forgot to come up with a process account, the abnormal gain or loss account. Okay, so let us just quickly do that so that we understand what is happening with the abnormal gain. So abnormal loss account. Okay, the abnormal loss or gain account for an abnormal loss situation is looks like this. In this situation, we also have got the units part, the dollar, the units, the dollar. Okay, so this account is going to be debited with the process account. The process account. All right, the process account. Okay, from the information here, okay, this information is going to just go straight to this point. So we are talking of 40 units which were in abnormal loss at $196. But I want you to watch something here. This $196 is for two accounts. Okay, it affects the scrape account, as well as the statement of profit or loss. Statement of profit or loss. All right, so our scrape account is going to be affected by the same quantities. Okay, 40 units. We're talking of the 40 units. All right. All right. So the statement of profit or loss, this is not part of the abnormal loss or account, but it is where the losses are going to be transferred to. Okay, the loss are going to affect our profit. All right, so that means, okay, so we don't need to worry about the quantities to the statement of profit or loss. No, we do not have to transfer the quantities there. All right. All right, but we know that the scrape is valued at 90 cents. So 40 multiplied by 90 cents, that should lead us to a $36. Okay, $36. But we know that this side should should add up to 196. Okay, to equal the debit side. So the difference is the transfer to the statement of profit or loss, which is an expense to the statement of profit or loss, which the difference is 160. All right, so we do the same thing here, all right, with the abnormal loss situation. Okay, remember these are just opposites. All right, you can see the process account in this case was on the debit side of this account. Okay, so here we are also going to have an inverse situation where we are having the process account on the other side. All right, so but let's deal with the scrap account first. The scrap account, like I said, is having a value of $90 because the scrap is valued at that amount, but 20 units have been extra units, so they are still going to be valued at 0.9 cents, dollars, so that's $18. Okay, but there is also going to be a transfer again to the statement of profit or loss. Okay, we'll determine that after we endorse our process account here, and these were 20 units. At what value? We just get this information from this part. Okay, that's the 98 we are talking about. So at 98, why 98? Because 20, if we say 20 at $4.90, okay, from the computations which we determined. Remember, the process account is valuing these abnormal losses or abnormal gains at the value of the cost per unit. So the cost per unit was $4.90. So 20 multiplied by $4.90, this should take us to some $98. All right, so if we total our columns, we should come to a 20 and to a 98. Then here do the same, and 20, 98. All right, so the transfer to the statement of profit or loss should actually be the difference, and in this case we are having 80 being transferred to the statement of profit or loss as a gain. Okay, so that's the gain that is going to appear in the statement of profit or loss. Okay, most students get confused and they want to transfer the whole gain of $98, which is wrong. Okay, or the whole loss, which is wrong. You need to consider the scrap impact, the scrap values. All right, so I hope we have done justice so far to our presentation, and because of the time, we are cutting the video here so that we will continue with the work in progress issues, where we now have the opening inventories, closing inventories, and also the work in progress matters. Okay, and also the other issues, the equivalent units of production, the joint product costing, the byproduct, all those items should also be covered as part of our learning. So see you in the next video. I'm signing out. Thank you.